All right, you guys, don't mind my hat, my giant eyelashes. Let's not talk about it. And my Saturday clothes. I'm recording for you guys on a Saturday, so better appreciate. So let's talk a little bit about 1.1 Introduction to Ecosystems. So we did an activity in class where we talked about the 5 different types of symbiotic relationships. Remember that a symbiotic relationship, not quite there yet. A symbiotic relationship is when you live closely with another organism and you're associated with that organism. So to start with, we should first talk about really what a niche is. So a niche or a niche is a job or a role. And all organisms have a fundamental niche anywhere they could possibly live and do their job, and then where they actually do. So for example, your fundamental niche is Florence and Penrose, that kind of area, western portion of Fremont County. But your realized niche is either Florence or Penrose, like your specific address. Because either way, you're going to end up going to Florence Junior Senior High School, but in such a way we have a large area that we could live versus where we actually do live. So each organism fulfills its niche and it has relationships with other organisms. Remember, we talked about mutualistic relationships in which both organisms benefit. We talked about commensalistic relationships in which one benefits and then one is neither helped nor harmed. It doesn't really care. And then we talked about a what's the word I'm looking for? Parasitistic relationship in which one organism benefits and the other one is actually harmed. And we can contrast that with like a predator-prey relationship. In both of them, one benefits and the other one is harmed. But in a parasitistic relationship, that relationship lasts over a long period of time, days, weeks, months, probably not years, but definitely a long period of time. Versus a predator-prey relationship is, minutes that the hunt goes on. And predator-prey relationships are really characterized by like hunting and killing, kind of like when you guys all go out and you go hunting. That's a predator-prey relationship. And we also talked a little bit about competition. So competition is when two organisms are going to compete for that same resource. We have a couple of different types of competition. We have intra-specific, where it's within the same species. So for example, when two male tigers are going to fight for a female tiger, or we have two male walruses, they will fight almost to the death to control a harem or a group of female walruses. And so that's intra-specific competition. They're also going to compete for things like food and space, but they're also going to compete for mates. And so this one makes intra-specific competition a little bit more fierce and more impactful on the organism. And then we have inter-specific competition where you're going to compete for the same food or the same space. For example, if a wolf and a bear are both going to compete for I don't know, you guys are going to criticize me, for an elk maybe, or they're going to compete for that same food source, that's inter-specific competition. And so what starts to happen is we have these two organisms and they're both competing and they're going to overlap, right? This can happen usually inter-specifically. So they're going to compete for the same resources, and you can see that where the brown and the green anole, which is a type of lizard, are going to compete and they begin to overlap. And what happens is we have what we call the competitive exclusion principle. And the competitive exclusion principle tells us that when two organisms are going to compete, one naturally is just going to be better than the other. And when they begin to compete, then one will start to win out. And you can see that on this slide where the blue one outcompetes the green one. And so it occupies more space than that green organism. And so what happens is the organisms begin to split up a resource, and they don't make a conscious decision to do this. They're just like, man, I don't want to compete. And if I'm down here, this guy, that's part of his fundamental niche, but it's not part of his realized niche. So I'm going to feed down here. And that leads to what we call the competitive exclusion principle. That leads to what we call the resource partitioning, where we split up a resource so that many organisms can access it. We see that overall biodiversity begins to increase. And so, for example, it can happen temporally, like birds feed on insects during the day, but bats feed at night. Or it can happen spatially. So if you take a look at the picture that's on the screen, right, we have a couple of different types of warblers. Those are birds. And so we see that the Cape May warbler lives at the very top. The black-berrien warbler lives in the top middle. The black-throated green warbler lives in the middle, but more sort of the top, middle top, below the black-berrien warbler. We have the bay-breasted warbler, and it lives towards the bottom. And then we have the yellow-rumped warbler, and it lives at the very bottom of the tree. We see that this happens in lots of different ecosystems. This can also happen in the savanna, right? Where you have a group of antelope come on and they eat the top of the grass. Remember, this is a tall grass prairie where the grasses are very, very tall because there's lots of rain. And so antelope come through and they eat the tall parts of the grass. And then a zebra herd comes through and they eat the middle part. And then a rhino herd comes through and they eat the bottom. The rhino herd is never going to come through and eat the top of the grass. In fact, it's probably taller than they are. But that antelope or that zebra is always going to eat the top and the middle, and then the rhino is going to live at the bottom or eat the bottom. And this way we see that overall biodiversity begins to go up. Biodiversity is how many organisms there are. We want to have high biodiversity, and resource partitioning allows us to do that. So I think this is topic 1.1. It's on your one pager, so I hope that this was helpful.